Left off on part C, fractional exponents. If you missed, you got to go back and check the video. Fill your notes in, okay? All right, this is going to be nasty, so bear with me. What rule is the first one for A? What rule is this? This is a product of powers. So what do I do with the fraction, or with the exponent? Add them. So you got 2/4 plus 1/4 x to the 3/4. It's not that bad, right? What do I do with a fractional power? The denominator becomes the index, and the numerator is still your power. Yep. Well, there's two ways to write it. What's the other way of writing it? Do the fourth root first, and then cube it. The one I wrote above says do x cubed first, and then do the fourth root. Either way is fine. All right, so part B. Same rule. Same question, basically. Just a little bit harder. What's hovering above x that's not there? A 1. So you're multiplying same base, so you add the powers. All right. How do I write 1 with a denominator of 2? 2/2. Now I can add the powers. What's 3/2 plus 2/2? 5/2. So this is the square root of x to the 5. These are hard because it relies on your knowledge of fractions and integer operations. So if you struggled in grade 9, 8, and 7 on adding, subtracting integers and adding, subtracting fractions, this is going to feel like death right now. Okay. This next one, you're dividing powers, so we subtract. My recommendation is to use the calculator if you struggle with this. Put 5/7 in a bracket, subtract -2/7 in a bracket, and it will do it for you. So in your calculator, if you struggle with this, that's what you put in your calculator. In a bracket, 5/7, bracket, minus, in a bracket, -2/7, bracket. Hit enter, math, fraction, enter, and it'll put it back in the fraction for you. So use the technology to help you if you've struggled in the past with integer and fraction operations. All right, so what's 5 minus -2? 5 plus 2, this is 7/7, which is just y to the 1, which is just y. Okay, any questions on that? A rat. All right, now we're on these ones. Part D here. What rule is this? Power of a power, so we will times them, times the powers. What do you do when you multiply fractions? The top to the top and the bottom to the bottom. So you have 1 times 2 over 2 times 3, which is x to the 2/6. That would reduce to x to the 1/3. So you need to know how to multiply fractions, you need to know how to reduce fractions, all while learning your new exponent laws. And that's why 10C can be a bit of a challenge for people, because maybe they didn't have so much success in junior high. Now we have x to the 1/3. What did I just do? X to the 1/3 would be a cube root of x to the 1, which I don't have to write. Okay, next one, E. A couple of rules on this one. What are they again? Well, there's like 3 rules. There's a power of a quotient, power of a power, and there's a Negative power. There's 3 rules on this one. So combined exponent laws. Okay, this is what makes it nasty. I hate negative powers, so I always deal with it. What do I have if I flip it? B over a squared to the power 1/2. Now I have a positive power. So now I've dealt with that rule. Now I have 2 rules left. I got quotient, power of a quotient here. So let's apply the 1/2 to the top and the bottom, right? So b to the 1/2 over a to the, what do I do here? It's power of a power on the bottom term. Say it in your head. What are you going to do? What do I do with this 1/2 and this 2? Power of a power. Times them. So say it in your head. What is 1/2 times 2? What's half of 2, guys? 1. And if you struggle with that stuff, literally put those operations into your calculator. So I go 1/2 in a bracket times 2, you get a 1. So this is just, yeah, it is just a, good. So fully simplified, what's b to the 1/2? Square root b over a. B to the 1/2 is square root b, all over a to the 1, which is just a. Okay, on to f. This is a power of a, say it, power of a, Chase, power of a, come on Chase, what's in here? Power of a product. Power of a product. So what do I do with this 4/3? It goes on to, so you'd have your exponent laws on the side, right? You're double checking. Okay, this is what I do in this situation, right? Got your exponent laws next to you, everybody? On your study sheet? So 8 to the 4/3 times a to the 1/2 times 4/3. Power of a power for the a. Because a already has a power. So if you bring another power in there, you times them. Okay, what do I do with the 8? 8 is a number. You can evaluate this. Usually they always give you the perfect cubes and squares. So that it always works out. You wouldn't have like weird decimals ever. Cube root of 8 to the power 4. Now what's the power going to be on a? When you multiply fractions, top to top, bottom to bottom, so this would be 4 over 6. All right, next step. What's the cube root of 8? 2. And 4/6 can be reduced to 2/3. So 2 to the 4 can be evaluated 16. And now what do I do with a? Cube root of a squared. How's that feel? Does it feel amazing right now? You guys are like, oh my gosh, hope that question's not on the test. Well, those of you that have been keeping up with your homework, you're going to have a good chance. Okay? Those of you guys kind of taking days off on Friday and then not even watching the video, oh, heartbreaking. But you still have 2 days to make it up. Okay? Are we on D right now? Okay. Is there any powers on the 5? There's a 1, right? Does the 3/5 apply to the 5? Just the x. Good. So what can you do with the 5 and the 25? Think about if it was just a normal fraction. What does 5 over 25 reduce to? 1 over 5. Okay? So that's the coefficient. Okay? That's the coefficient, that's what it'll end up being. Now, what do you do with the x? And like when I look at this x, this is what I literally see in my head. This is what I see. Those guys go together. That's what I see. The other thing that I see is this. Those guys go together. That's in my head. Because I have experience. You guys need to put the work in so that you can start seeing things like this. Okay, so what do I do with the x? Is this a quotient of powers or a power of a quotient? It's a quotient of two powers. You're going to divide powers. So you have to subtract. When you subtract, it's always going to end up in the top. So you have 3/5 subtracting -3/5. What does a subtract negative do? Owen, you following along? So we add. Okay, so literally this is like, if I had a different color pen, just go like that. So it's 6/5, right? X to the 6/5. When you subtract off that rule, the result is always in the top. Okay? Now, let's make this answer a little bit more cute. Do I need this one? No. Change the fraction power to a radical. What type of root is it? A 5th root, x to the 6 all over 5. Look how much cuter that looks. What do you mean it doesn't look cute? Oh, you think it looks sexy? Doesn't it look better than this guy? This is like me on a Sunday. This is me on a Monday. I'm just kidding. Trying to lighten the mood in here. You guys are so scared of math. It's not even funny. Okay, let's take a look at E. Let's assess the situation. Is there powers on 2 and 5? Not really, there is, but there's ones, but like I'm talking about, does the 3/8 and the 1/8 apply to the 2 and the 5? No. So literally what you could do is put the 2 and the 5 together. What does 2 and 5 make? Don't say 7. I've seen some people adding before today. I saw it. So 10. 2 times 5 is 10. Now what do I do with the x powers? Addition in the powers, because it's a product of powers. Good. So 3/8 plus -1/8. Sorry. Okay, what's 3 plus -1? 2/8. How does that reduce? 1/4. So what type of root is it for x? A 4th root of x. Now we're into some nasty. F. What's going on in F? What's going on in F? Read the exponent laws worksheet. What are the exponent laws here? Quotient of powers and a product of powers. Okay? So if I were to just write this using y, I got 2/3, I got a half, and I got a quarter. What do I put between the 2/3 and the 1/2? A plus sign, because you're timesing there. What do I do with the 1/2 and the quarter? I minus them. But I should probably figure out this one first and then minus. I honestly don't think it'll matter, but we should do it that way. Okay. So, like, would you guys ever probably write it like that? I doubt it. I doubt it. What would you guys do probably? Would you do this first? I'd probably just do that first, wouldn't I? Okay, so let's do that. 2/3 plus a half. Now, could you cheat with your calculator? Yeah. So in your calculator, 2/3 in a bracket plus 1/2 in a bracket. You should get this. If you want to do it by hand, you need a common denominator. So I'm going to times that by 3, times that by 3, times this by 2, times this by 2. I end up with 4/6 plus 3/6, which is 7/6. Anybody get 7/6 in their calculator? Look at that. Shouldn't have to do any of this grunt work. Okay? Like the grunt work? Okay, so now I got the top. It's y to 7/6. So y 7/6 divided by y 1/4. So what do I got to do now? Quotient of powers, I would have to subtract. Are you going to do the grunt work or are you going to cheat in your calculator? Cheat in the calculator? Yes, you do that one. Use the fraction button. Little ABC button. So you go 7, ABC button 6. Put your hand up if you have no idea where the fraction button is. Put your hand up. You don't know how to use fraction button. Oh, so you guys know how to use the fraction button. You don't have a fraction button. You use division. 7 divided by 6, take away 1 divided by 4. Math fraction. Yeah, 11/12. Okay? You don't know how to use a fraction button? You figure that out today. I'm getting y 11/12. Cheating on the calculator. It's not cheating, it's using technology to your advantage. Dude, they make you buy it, it costs $100 and some odd, you use it. Now, if you're headed to university, and you know you're going to university, and you know you want to take calculus because you know you're going to take a science program, then absolutely you should be trying this by hand. If you do not think that your life is going to involve, math at the highest level, then use your calculator. Like if you think you're going to go join the Olympics for weightlifting, then don't use your calculator. Right? If you're going to be a doctor and you need calculus, do it by hand. Okay? What are you going to be, a bum? All right, now we're into some good ones here. Is this on the next page? Okay. These ones are what the test is going to be like. Like this one. This is what the tests want to look like. It's not even that bad. Just clean up the inside and then apply. Well, there's always different strategies. Yeah, you could clean up the inside, and I've said that in the past, but I personally hate those. I hate that. So what I could do right off the bat is rewrite everything just flipped. Nothing changes. Everything's the same. Just top and bottom, and now I can switch that -2 to a +2 if you just switch everything. Now we can think about this question. Now I like to clean. Clean up inside. That's what I like to do. Okay? Yeah. So, and hopefully you're starting to think about columns at this point. It's like, and colors, like math and colors is a big thing. Those guys go together. Those guys go together. And those guys go together. And all of them are applied to this power 2. Okay? So you still have this thing to the power 2. So let's do the yellow. What's the result of the yellow? 3 over 1. Is it still yellow? Sure, why not? Now let's do the m's. How many m's do you have altogether? 2 in the top and -3 in the bottom. That's weird, right? You have -3 m's in the bottom. That doesn't even make sense. Does it make sense that you have 2 m's in the top? M. Does that make sense? Yeah. You have m to the -1, m to the -1, m to the -1 in the bottom. Does that even make sense? No, so make it positive. Where would that go? To the top and become +3. Now how many m's do you have in the top? M5. That's how I think about it. I have a ton of experience though in math. So, if you don't have that experience, you can plug away on the formula. What does it say to do with m? 2 subtract -3. What's 2 take away -3? +5. Okay. Now what about the ends? Okay, I gotta start over because it's messy. Okay. So give me a sec to catch back up. 3 over 1. 2 minus -3. What do you write for n? What's the power for n if I follow the rule? 2 take away 2. And all this to the power 2 on the outside, right? We still haven't forgotten about that. Now we can clean this up. 3 m to the 5 n to the 0 all to the 2. What's n to the 0? 1. Could you just go on like that? N squared divided by n squared? Sure. Now what's 3 m5 squared going to be? 9m 10. There's a bunch of these in your textbook. You better try them. Or else basically you're forfeiting like 4 marks on the written response if you don't try these. And I'm basically going to be looking for any application of the exponent laws properly. So even if you do one thing in this question correct, I'll give you some part marks. Does that make sense? All right. So let's try this one. This looks horrible. This looks quite scary. I gotta take the square root of all that? Maybe we should clean it up first. Alright, so what did I do first up here in yellow? The numbers, right? So let's deal with the numbers. What's 100 on top of 25? Good, that's just 4. How many A's do you have? 1 on top? No. 1 on top and 5 in the bottom. That's how I think about it. How many A's you got? 1 in the top, 5 in the bottom. They're going to have a little fight. Who wins? The bottom. Bottom has more guys. How many are left over after the fight? 4. In the bottom. The bottom was winning, right? So if you were to do it on the side with the rule, what's 1 take away 5? -4. If it's negative, put it in the bottom. The rule will always leave you in the top. If you use the rule, it leaves you in the top. So we know that there is A4 in the bottom. Now if you think about this just using logic, there's 1 on top, 5 in the bottom, they have a little fight, 1 gets canceled, there's 4 left over, the bottom was dominating, right? Or you can use the rule. 1, take away 5, negative. The rule always leaves you in the top. If it's negative, put it in the bottom. Now, is there anything connecting this B to anybody? Or is he just by himself? There's only one term with B, right? This is the only thing. So if it's negative power, where should it go? To the top, and then it no longer will have a negative power. And we still haven't done anything with that power 1/2 out there. So you still got to keep that guy there. What did I do? All I did was clean up the inside. 100, let's review. Everybody, what's 100 divided by 25? 4. What if the 25 was on top and the 100 was in the bottom? Would it be 4? Or would it be 1 over 4? The 4 would be in the bottom, right? Good. How many A's on top? How many A's in the bottom? How many left over? In the... Good. What do I do with negative powers? Move them from the... If they're in the bottom, they go to the... If they're in the top, they go to the... And you switch negatives to negative power, positive power. Negative power, positive power. Now what do I got to do in this step? What's the only thing that's left? That guy there. So what do I do with that power? Apply it to everything. 4 gets it. B gets it. What's going to be the result on B? Oh, geez. It's multiplication. What's a half of a half? You cut a half in half, you get a quarter. 1 times 1 on top, 2 times 2 in the bottom. All over A to the... What's half of 4? 2. What's 4 to the power 1/2? Square root of 4 is... And then what's B to the 1/4? 4th root of B, all over A squared. You guys are not feeling this. Last 2. I'm going to go quick. Okay, 4 to the minus 2 plus, so this is different than what we've seen in the past. Usually that's a times, right? So if it was a times, then you could add the powers, but that's not what's going on here. So you have to literally do these separately. So what's 4 to the minus 2? Not negative 8. You never, ever just times those. You do that, so scary. Don't do that. Okay, 4 to the minus 2 is like 1 over 4 to the 2. What's 4 to the minus 1? 1 over 4 to the 1. All over, I already did this one. Are people okay with that? All I used was the negative rule. What's 1 over 4 squared? 1 over 16. Plus 1 over 4, all over 1 over 16. Now what do I do? Adding fractions, I need common denominator. So the common denominator for 4 and 16 is, so put a 4 there, put a 4 there. So what's 1/16 plus 4/16? 5/16 divided by 1/16. Now you're dividing fractions. So let's rewrite this so it looks more normal. All I did was add fractions. Now I'm about to divide fractions. How do you divide fractions? You change the divide to a times and you reciprocate. Nice thing is 16, 16 cancel. This answer is just 5. Could you have put this in your calculator? Probably. But the process, I have to teach it. It's my job. 80% of you probably will never need it in your life and don't care about it. But there is 20% of you in here that will need this. And it's those of you that are going to calculus. That's kind of the problem with 10C. Like, there's lots of stuff in 10C that the average kid does not need. But that's the way it goes. All right, the last one. They give you this crazy formula. I think this question shows up in your test in the multiple choice. Really, the preamble doesn't really matter. Okay, S stands for sleep, P stands for protein, C stands for grams. They want you to find E, find the amount of energy E. Okay, and 8 hours of sleep, so I can change the S to an 8. 10 grams of protein, so I can change the P to a 10. And 100 grams of sugar. This must be, C must be for sugar. So 100 down here to the 1/5. Now, this is something I would put in my calculator because, like, what's the square root of 10? Is that a perfect number? No, that's irrational. So I would just stick this into my calculator. All right. Where's the calculator? Could somebody read that equation to me? Was it 8? 8 cubed times 10 to the power. If you got this calculator or any of my scientific calculators, how many of you guys got scientific calculators? If you have that little hat, see that little hat for exponent? You have to put your power in a bracket. Okay? That's going to figure out the numerator. What's the denominator? What is it? 100 to the power 1/5. So see how it says answer divide? So I calculated my numerator, then I hit divide, so it's my answer from above divided by this. And notice I use the brackets. Brackets for powers. If you have an older model or a scientific model. So there's the answer, 644 joules. Does it say like nearest tenth or something?
Yeah, it says nearest 10.
So 644.6. Yeah, because you have a nice calculator. Your calculator prompts the powers up there, others don't. And the fact that you have a bracket around the denominator is beautiful.
I did it without the brackets too, and I got the same answer.
Oh, whatever. Okay, so 644.6 was it? Oh, where's my screen? 644.6. Okay, so at the bottom of your page, hopefully. Oh, it's on the wrong screen, is it? this to me. Okay, so there's the answer, 644.6 was the kilojoules. Now, on Friday, I told you to get started on these. So this in the circle, technically, this in the circle should technically be your homework right now, that you have about 15 minutes, 13 minutes. Okay. So, I'm going to be coming around checking your homework. Okay? So when I'm in front of your desk, you show me your work.